interfaces can have multiple types of methods. You can have, so interfaces can have abstract methods, methods. They can also have default methods. And recently I learned that they can have static methods. I don't know if this is true, but the most common ones are you have abstract methods and you have default methods. So an abstract method is, for example, this. Somebody in the chat can confirm for me if this idea of static methods in interfaces is true. Interesting stuff. But anyway, abstract method is like this, and default methods is like we covered when we're doing interfaces. So you can have a default method here that perhaps does register stop. So maybe they have multiple stops they need, and it's of course it's a method, so it's a return type, and all it does is it registers the stop. So i.println register stop at perhaps a particular timestamp, maybe system.current time. So you can just register the stop at whichever time that was. So if they stopped, this function will be able to register the stop. So this is a default function. This is an abstract function. So interfaces can only have one and only one abstract functional interfaces can only have one and only one abstract function. And the reason why they need to have only one and only one abstract function is because if they have more than one abstract function, you cannot use them as lambdas. Because with interfaces, you have to implement all the abstract functions in there. So if we had another abstract function here, like void stop, so you are driving, you can also stop. If we added this abstract function, we'll see that all our lambdas are now broken. They're gone, they're kaput. They're gone because this mechanic of functional programming in Java depends on functional interfaces. And functional interfaces are interfaces that have one and only one abstract method. If there's more than one abstract method, you'll go into, your whole program will go into a stroke and it will stop functioning. So, so that's something important to remember. So because of the idea of functional interfaces is how we get to have lambdas. Without that, we can't have lambdas. So if your interface has more than one abstract function, you can say goodbye to lambdas. And to ensure, because interfaces can be implemented later in your program, you can declare an interface and some other developer will implement it, maybe some user of your library will implement it. You might declare an interface, expect that whoever implements it uses common sense or has the esoteric knowledge of knowing this is an interface with only abstract function. I will not add another abstract function to it, or I will implement it using, I'll use lambdas with it to make sure that you communicate to the users of your interface that it's a functional interface. Java provides a very nice utility annotation that you can annotate your function with. So you can annotate your function with this functional interface annotation. Two important things with this. One, it allows you to communicate to the users of your interface that this is a functional interface. So it can be used with lambdas. Second thing, it allows you to get compile time checking for this one and very important rule of not having more than one abstract function. So if I didn't have this functional interface annotation, I could just go ahead and add an abstract function here, perhaps say stop like we had. So the interface itself will not have, there won't be any compile time errors. So the implementers are the ones that are going to suffer. They're the ones who get their heads chopped off. But if I want to ensure that while I write this, that is already picked up, what I can do is I can have this annotation for functional interface, and I can, by having that annotation of functional interface, whenever I try to add an additional abstract function, that is picked up and it's already detected for me at compile time. So they pick it up and the Java language picks it up and already gives me an error. So you can see multiple non-overriding abstract method found in drivable. So for the only way this code will compile is if I remove that additional function. So if I remove that function, then everything will be very nice. Everything will go very well. But if I have that functional interface annotation and I try to implement an additional abstract class, everything goes sideways. So yeah. So this is very important for you to remember. This idea of functional interface drives into a lot of additional things inside the Java language. It will allow you to work with many additional APIs that we cannot cover here. Of course, we'll cover them later. Namely, as I usually like to name drop the comparator interface, the predicates, the consumers, the producers, and suppliers, which allows you to do other levels of functional programming. And we'll cover them in later sessions.